I've had quite a few people reach out about these types of problems, so I wanted to take a minute and walk you through the process for these. Once again, you can use a U substitution. Maybe you figured out how to do this without doing a U substitution, and that's fine. I want to caution you that what you cannot do is raise everything to the fifth power, okay? Because then you'd have to take that expression that you see and multiply by itself 5 times, and that gets really messy. So what you need to do is think about how you can factor this just as it's written. But our question becomes, how do we know it's a quadratic? And here's how we know. A normal quadratic, like x squared minus x minus 12, we can tell this is a quadratic because our linear term, our middle term, has a power of 1. Our leading term has a power of 2. Because we can multiply the linear term 1 by 2 to get 2, we know it's quadratic. In other words, this is exactly half of that. Okay, so when I look at my exponents, I've got x to the 1/5 and x to the 2/5. If I multiply 1/5 times 2, I get 2/5. Therefore, I can tell that this is a quadratic. So then my substitution is going to be just saying, all right, I'm going to call u whatever the middle term is, all right? So I'm going to call u x to the 1/5. I ignore any coefficients. I just use the variable and the exponent. So then what I can tell is that I'm going to replace that with u. And then I know that I would have to raise x to the 1/5 to the power of 2. In other words, I have to multiply it by 2 to get 2/5. So then I know that it's going to be u squared. As long as I see the pattern, I can rewrite this as a quadratic really easily. And then I factor it. Now, I'm not going to spend a lot of time factoring here. I believe you should be able to do this at this point without too much trouble. Set it up so you have u minus 4 equal to 0, u plus 3 equal to 0, and solve for u. So we get 2 values for u. Now, what do you do with that? Well, we have to go back up to what we originally replaced u with, right? So u is actually x to the 1/5. So what I'm going to do is I'm going to set up 2 equations. 4 equals x to the 1/5, and -3 equals x to the 1/5. Now I have to solve that. So we need our solution to just be x to the first power. Well, the only way we're going to get that is if we raise x to the 1/5 to the 5th power, because that's going to give us a 1. So that means we have to raise both sides of both equations to the 5th power. And then I'm going to get just x equals, and then I'm going to type into my calculator 4 to the 5th power and get 1,024. And then I'll have to do -3 to the 5th power. Now be careful with this because you want to make sure you put that -3 in parentheses. Otherwise, it's going to do, it won't mess up this one necessarily because we're doing it to the 5th power. But if it were an even power, it might give you a negative answer when in fact it would be a positive answer. So 3 to the 5th power, or -3 to the 5th power, is -243. So those are our 2 solutions. Now I'll leave the check up to you. You can plug it back into the original expression and make sure that it works. I think it will with this one. Let's try one more. So once again, we're going to look at this and determine whether or not this is a quadratic. So I look at the middle exponent and I look at the leading exponent. If I can take the middle exponent and multiply it by 2 and get the leading exponent, then I know that it's a quadratic. So I can tell in this situation that this is a quadratic, okay? So then I'm going to decide that we're going to call u whatever this middle variable and exponent are, ignoring the 4 in front. All right, so now I can start replacing things. I know I have to multiply -2/7 by 2, so it's u squared minus 4 times u minus 5 equals 0. And then once again, we've got a factor. And then solve for u. Always going back to what you decided to substitute u for in the beginning. So we have u is actually holding the place for x to the -2/7 power. So I'm going to rewrite my 2 solutions as 5 equals x to the -2/7 power and -1 equals x to the -2/7 power. Now you've got a few options here. Our goal is to ultimately get a 1 as our exponent on x. I'm actually going to split this up into 2 parts. Okay, so the first thing I want to do is I want to get it so that I have just a whole number for my exponent on x, okay? So I want to take and make this, raise it to the 7th power, okay? Because what that's going to do is it's going to get rid of the 7 in the denominator in both of my exponents. So I need to raise both sides to the 7th power. So I'm going to get x to the -2 on my exponent for x, and then I've got to figure out what 5 to the 7th power and what -1 to the 7th power is. -1 to the 7th power we know is just going to be 1, and then use your calculator to find 5 to the 7th power. And that's going to be a big number, so 78,125. All right, now the -2. So lots of ways you can go about this as well. I want you to remember what a negative exponent actually means, okay? A negative exponent, so if I have x to the -1 power, that really just means 1 over x to the 1st power. So it's really doing the reciprocal, okay? So I'm going to rewrite this so that I have the reciprocal. And this is what we've done when we were practicing with our exponent rules a few days ago. Now, because I have a fraction on one side, I'm going to put a fraction on the other, so I'm just going to write it over 1. And now I've got a proportion, so I should be able to solve this proportion. I'm going to do the 1 on the right side first. So I'm going to cross multiply, and I get -1x squared equals 1. I'm going to divide both sides by -1. And then if I take the square root of this, I get plus or minus the square root of -1. That's a problem, okay? So I don't get any solution from this. Let's do this on the other side. So 78,125 equals, times x squared, sorry, equals 1. Okay, so now I have x squared equals 1 over 78,125. And I've got to take the square root of that. Now, if 78,125 is a perfect square, it's going to be great. If it's not, I want to try to leave it in exact form for as long as I can. And it's not. So what I'm going to do is this, x equals plus or minus, and I'm going to think of this as the square root of 1 over the square root of 78,125. And then we're going to go back to what we've done with when we were practicing on the unit circle, and we're going to rationalize the denominator and all of that good stuff. So let me actually move this up here. So I have x equals plus or minus 1 over the square root of 78,125. And then I'll multiply top and bottom by the square root of 78,125. Now, I'm not even trying to simplify this right now, so it might be able to simplify. And if it could, that would be great. This is kind of a large number. It's way more than you guys are going to encounter. So I just want you to see the process more than anything. All right, hope that helps. Let me know if you have any questions.